Welcome to my YouTube channel. Dhanesh here. See, this is the second video on the electrostatics theory part. See, we uploaded many videos related to IIT JEE questions and solutions, but related to theory, electrostatics theory. This is the second video. So in this part, we are going to discuss about electric field and intensity of electric field and electric field due to a point charge. These aspects we are going to cover. In the last video, we covered what is electric charge and Coulomb's law. See, electric charge is the fundamental quantity in electricity, and its unit is Coulomb. And the charge of an electron, that's very important, it is 1.6 into 10 raised to minus 19 Coulomb. That's really important. You have to understand, in the last video I am again revising whatever we discussed. Here one important thing you can remember here is charge of an electron is 1.602, or you can remember it as 1.6 into 10 raised to minus 19 Coulomb. C stands for Coulomb. Coulomb is the unit of charge. This is an important aspect. That's the charge of an electron. Now, sorry. Another thing we discussed is the condensation of charge. You please watch the previous video. It is plus or minus Ne. This is the condensation of charge, where n is equal to 1, 2, 3, etc. See, what is condensation of charge? The charge occurred by a substance is an integral multiple of the basic unit of charge. After that, we understood the Coulomb's law, the mathematical statement for Coulomb. Before that, I will tell you the statement in the exam, in the board exam. If they are asking what is Coulomb's law, you need to write the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And the mathematical statement for Coulomb's law is, this is the mathematical statement, and it is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. So this is the mathematical statement, and epsilon 0 is known as the permittivity of free space. Epsilon 0 is known as the permittivity of free space, and its value epsilon 0 is equal to 8.85 into 10 raised to minus 12 Coulomb square, Newton raised to minus 1, meter raised to minus 2. All these aspects we covered. You can watch the previous video as well. And one more aspect today I am going to discuss is that what is superposition of a superposition principle. That means if multiple forces acting on a single charge, what will happen? So the situation will be like this. See, you can understand, for example, this is a question asked many times. You may be knowing it. For example, you have a square of side A, and the charges are placed here. You have charges up in this corner Q1, it can be plus, this can be minus, Q2, this can be plus, Q3, this can be minus, Q4. Then what is the net force acting on any one of the charges? They can ask like that. For example, what is the net force acting on plus Q1? Then here you need to understand one important point. This process, we call it as the superposition principle. The important point is you have to understand force is a vector quantity. So we are calculating the net force on plus Q1. So since force is a vector quantity, we have to do the vector addition. This point you need to understand. You cannot calculate the force and you can't add it, because vectors won't follow the ordinary rules of algebra. So vector addition, you have learned triangular law of addition, parallelogram law of addition, all these aspects you might have learned. See, in the same way, if we take the force due to Q4, I am calculating the difference. There are three forces coming into picture. One is due to minus Q4. What would be the force on plus Q1? Minus Q4 will be this. Minus Q will attract. So the force will be like this. This is due to the force due to Q4. And this minus Q2 also, it will attract. So it will towards that minus Q2. So it will be, this is force due to minus Q2. But Q3 will repel. So the force will be towards the diagonal, right? So it would be, this is the diagonal. So it will be repelling like this. So this is the force due to Q3 on Q1. You understood? So this is the force FQ4. This is the force FQ2. What is FQ2? It is due to the force charge Q2. And this is the force FQ3 in this. So these three forces you need to do the vector addition. That's what you have to understand. So these angles will be equal, because the total angle. See here, when you consider these two forces, they are mutually perpendicular. So this is 90 degree. So first you can calculate the resultant of these two forces by using parallelogram law. That is R is equal to root of P square plus Q square plus 2PQ cos theta. Here theta is equal to 90 degree. Then you will get the net force here. And then these two forces are opposite direction, and then you can subtract. So this is the process, because what I am telling is, when you add different forces on a particular charge, or when you try to calculate the addition of forces due to Coulomb's law or any type of force, you need to use the superposition principle, because it's a vector quantity. This is a simple example I have given you, so we can do the numericals based on this as well. I have explained you the process you need to follow while doing this numerical, and this is known as the superposition principle. That also we discussed, and in the last video I told you how you can write this thing in the vector notation also. See, if you are writing Coulomb's law in vector form, you will write it like this: vector F is equal to 1 by 4 pi epsilon 0 into Q1 Q2 divided by R square into R cap. Cap denotes unit vector. I cap is the unit vector along x-axis. J cap is the unit vector along y-axis, and k cap is the unit vector along x-axis. See, all these aspects you are familiar. Now I will get into the next thing we are going to discuss in this chapter is very important, really important. That's electric field. So I will discuss about electric field. So what is electric field? First of all, I will tell you, when we introduce the concept of field, see, the concept of field we usually introduce in the case of non-contact forces. See, force is of two types. One is contact force. Another one is non-contact force. Force is of two types. One is contact force, and the second one is non-contact. So I think you didn't understand that. I will explain you. For example, if you want to take your phone, all right, you need to touch it, because you need to have a contact. But when a magnet if a magnet wants to attract another iron piece or another magnet, even without touching it, that magnet can do it. And that is the same case with charge as well. That's the same case with the gravitational force as well. So what I want to tell you is all mechanical forces are contact forces, but there are non-contact forces. Example, electrostatic force, gravitational force, magnetic force, all these are all non-contact forces. You understood the concept? See, in the case of non-contact force, we will always introduce the concept of field. You might have heard of gravitational field, electric field, and magnetic field. So field means in that region. For example, when you consider a magnet, because you are familiar with this, when you consider a magnet, there should be a region around surrounding the magnet where you will get force of attraction and repulsion. For example, if you have a magnet here, surrounding a particular area, if we bring another iron piece or another magnet, it starts attracting. So this area we call it as the field of this magnet. Inside this field, if we bring another magnet, it starts attracting. This is, we call it as the magnetic field. In the same way, if you consider a charge also, the same concept you can tell. For example, I have a charge plus q. You can see it here. If I am considering a charge, a plus q here, this is a plus q charge. So surrounding this charge, there is an area where if I bring another charge, it will attract or repel. If I bring positive charge, it will repel, and if I bring negative charge, it will attract. So this area we call it as the electric field. So what is electric field? Electric field is the region around a charge where electric force of attraction or repulsion is experienced. What is electric field? Once again, I am repeating it. It is really important. Electric field is the region around a charge where electric force of attraction or repulsion is experienced. Electric force of attraction, if I bring another charge, you will get a force of attraction and a repulsion. Electric force of attraction or repulsion is experienced. So this is the definition. This is the concept of electric field. Electric field is not a physical quantity. You need to understand it's a quality. See, even in physics and chemistry, you define quantities and qualities. First you define a quality, after that you define a quantity. Sorry. So the quantity, to measure this electric field, we call it as the intensity of electric field. So the next term I am going to discuss is about, intensity of electric field. What is intensity of electric field? So to measure the strength, the intensity of electric field means we need to find out the strength of the electric field. To measure the strength of the electric field, what we need to do is we need to bring another test charge. Test charge is used to, excuse me, test charge is used to measure the strength of the electric field. So we will bring another unit positive test charge near to our charge and see how much force is experienced. I will show you here. See, we have a charge here. This is our charge. This is Q amount of charge. So this is our electric field surrounding this charge. So what I will do is, if I want to understand the strength at this point A, I will bring a test charge. Test charge, very important. Always it is taken as unit positive. So we call it as unit positive test charge. This is the charge we are bringing it here to measure the strength. So we will bring a unit positive test charge means it is plus 1 coulomb. That's all. Unit positive test charge means both are same. This plus 1 coulomb and unit positive test charge both are same. I will bring plus 1 coulomb charge here. Then how much force is experienced? That force, we call it as the intensity of electric field at this point A. When you come closer, the force will be more. When you move far away from this charge, the force will be less. So the intensity of electric field, it varies. It changes from point to point. When you bring this charge closer to this charge, the force will be more. If you bring the charge far away from this, the force will be less. So that is the concept of intensity of electric field. Excuse me. Now, to understand, the definition, these concepts we need to tell it in a definition. That's all. So, what is intensity of electric field? Intensity of electric field at a point is defined as the force experienced by a unit positive test charge placed at that point. So what is intensity of electric field? Intensity of electric field at a point is defined as the force experienced by a unit positive test charge placed at that point, because intensity of electric field, as I told, it varies from point to point. So it will be less far away from this charge. When it moves towards the charge, it will be very high. So the definition I told you, I told you like intensity of electric field is the force experienced by a unit positive test charge placed at that point. That means I defined it for unity. For example, you usually define velocity is the displacement traveled in unit time. Then you will write velocity is equal to displacement by time. This is the way you write the formula. You define it for unity and divide with time. See, if it is defining for unit time, divide with time. So velocity is the displacement traveled in unit time. Velocity is equal to displacement by time. Intensity of electric field is the force experienced on unit charge, unit positive test charge. So intensity of electric field, the formula for intensity of electric field, E is equal to, I can tell you, E is equal to F by Q. Intensity of electric field is a vector quantity. This is the first point you need to understand. Intensity of electric field is a vector quantity, because this you no need by heart it. From the formula you can understand force is a vector, charge is a scalar. So vector by scalar is a vector only. When you divide vector with a scalar, you will get a vector. So in the same way, so intensity of electric field is also a vector quantity. And the next thing is unit. Unit will be, from the formula you can tell, Newton per Coulomb. Newton per Coulomb or Newton Coulomb raised to -1. If you want the dimensional formula, you can write it is MLT raised to -2 is the dimension for -2. MLT raised to -2 divided by what is the dimension for Q? I told you in the last class it is A into T. You can see the previous video. So it should be, the dimension should be MLT raised to -3 A raised to -1. This should be the dimensional formula for intensity of electric field. So we covered in this video electric field, intensity of electric field. Now I am giving you the first formula, the second formula of Coulomb's law. We already finished, covered some of the formula. Now the electric field, it is really important. It is F by Q. You need to remember this formula as well. Now the next topic here we are going to cover is the you know, intensity of electric field due to a point charge. It's a very simple derivation, small derivation. So what we are going to cover here is intensity of electric field due to a point charge. Intensity of electric field due to point charge. So what we are going to discuss, you have a point charge Q here, and R is a point, sorry, P is a point at a distance R from this point charge. What is the intensity of electric field at this point P? As per our definition, as per the definition, what we need to do is we have to put a unit positive test charge here and find out the force. So we are keeping. So again, I am repeating it as per our definition. The intensity of electric field is the force experienced by a unit positive test charge. So based on that definition, we are keeping a unit positive test charge. That means plus 1 Coulomb here, and find out the force. That force is the intensity of electric field. So intensity of electric field is the force on unit charge. So what is this force? So E is equal to, what would be this force by Coulomb's law? 1 by 4 pi epsilon 0 Q1 Q2 by R square. Q1 is Q, Q2 is 1 divided by R square, distance is R square. So the formula becomes 1 by 4 pi epsilon 0 Q by R square. So this is the important formula, very important. So what is the intensity of electric field due to a point charge? 1 by 4 pi epsilon 0 into Q by R square. This is a very simple, derivation. Intensity of electric field due to a point charge is E is equal to 1 by 4 pi epsilon 0 into Q by R square. See, so two formulas we covered for intensity of electric field. The first formula we covered is E is equal to F by Q. The next formula we covered is 1 by 4 pi epsilon 0 into Q by R square. Very important. And from Coulomb's law, another formula we covered in this chapter is 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is from the Coulomb's law. See, that's all about this video. So in the next video we will be covering the next aspects like electric lines of force. All those aspects will be covering. Thanks for watching.